Thank you, Professor Willerth, for joining our podcast. It's really, it's an absolute pleasure to have you because, it's a pokey podcast that we have here, and somebody as distinguished as you to be here. I truly, really appreciate it. So, to start off with, if you could tell us a little bit about yourself and your bit of your background and your area of expertise as well.
Oh, for sure. And first of all, I'm also really excited to be here. It's always great to talk about the work we're doing. So my day job, I'm a professor in Canada Research Chair of Biomedical Engineering at the University of Victoria. I think this is an international audience, so we are north of Seattle and west of Vancouver. Sometimes I do get confused students from Australia who think we're down there.
Oh, yes, of course.
Yeah, my lab does a lot of work using 3D bioprinting to generate human tissue models. And I also have spun off a company from my research lab called Axolotl Biosciences, where I'm the CEO. I always wanted to be a professor, so I did the whole academic track of, double majoring in undergraduate, doing a PhD in biomedical engineering and a postdoc before starting my faculty position in 2010 here at the university. And ever since I was little, I've always been really interested in science, and in particularly biology and cells. And that kind of makes sense given what my career's turned out to be.
Absolutely. And, of course, we've had a chat before as well. And, all your, in your career, you have, been cited so many times. You've done a huge amount of work. That's incredible. So that's why I was saying earlier that it's really amazing to have you here. Before we get into your amazing career, I would like to start off with a bit of our usual question that we ask from all our guests. That is, what is a book that may have impacted your life to start off with?
Oh, yeah. So I'm all over the place with my book selections, but I think the first one, because we're getting into childhood and college, is The Girl's Guide to Hunting and Fishing by Melissa Banks, which is a set of short stories about dating and relationships. And it was one of those things I read over and over again when I was an undergraduate at MIT, just because I think it's a really interesting insight into how people relate to each other. And also how, as you grow older, like how you perceive things when you're younger, you can look back at certain situations and relationships and see them in an entirely different light than when you're actually going through it. So it's one of those books that I always really like to read and reread every now and again.
Absolutely. It's one of the, those books are, kind of impactful in a way that almost sets you up, your way of your thinking and things like that really influences your whole life almost, right? So it's something that you can always go back to, especially those books that you read at that age when you're little, right? So as you say, going back to your early childhood, of course, you were very interested in science and all STEM subjects. Tell us a little bit about how you got interested in science in the first place when you were in school.
Oh, even before, even when I was in kindergarten, my parents infamously dug this up. My Christmas list when I was 5 was for a chemistry set and tickets to a college football game.
Wow.
I did actually, and it still sounds really good. I did get the chemistry set, and for any students out there listening, I did everything they said not to do. So they'd be like, "Don't mix these chemicals." I'd be like, "I'll be in the backyard." And then in junior high and high school, I did the science fair, science Olympiad, and took a lot of different science courses. And I knew I really wanted to go into biology at the time. I did my senior high school thesis on Dolly, which was news at the time, cloning the sheep. And so I was fascinated by stem cells, the idea that a cell could repopulate a whole animal. And that's why I was really interested in biology. And then when I got to MIT, I realized I always knew I wanted to be a professor and teach and have a research lab. And then I realized if you did an engineering degree, you didn't have to postdoc as long. So then that's when I majored in chemical engineering. So
sorry, when you were in school, did you decide to go to MIT because it's an engineering school or because you like Boston to start off with? And is that why you kind of went that way?
Oh, I went there because it was the best, one of the best schools for biology that I was interested in majoring in. So I applied there, and the University of California, San Diego, which was the best public school for biology. And I also knew I'm originally from Missouri. I really wanted to do research. And so schools like MIT, where they had a big emphasis on undergrads being able to do hands-on research, was something that was really important in my decision-making process.
That's very interesting, right? So last week I was speaking to Dr. Frederick Snyder. He is a behavioral economist. So I was asking him, like, why did you wanted to go down the path of being a researcher versus, once you've done your undergraduate, why didn't you just, you've done your undergraduate in something really prestigious. Why did you not go to a corporate world and things like that? So, I mean, you, of course, wanted to do research since you were very little. And after you finished your degree in MIT, did you not have like a moment to think about, should I go into research, or did you not have any doubts at that moment? Whereas you did a MIT, I mean, you could have gone anywhere and got any job, right? Like there should not be a problem. But you still kept on with that path. That's really, really amazing, I think.
Oh, well, it's interesting because I probably graduated both my undergrad and my PhD at like the worst times for jobs. So I was graduating 2003 when the US, I was in Boston when 9/11 happened. And then, so it was interesting because I did apply to both graduate school and jobs. So I did interview. But once I had gotten into graduate school, I got into graduate school relatively early to Washington University. I was really excited about their program. So I did interview for a few other jobs, but I always was like, I really want to be a professor. I also point out there's like no guarantees that you will become a professor. And so I always was looking at both. And even during both my PhD and postdoc, both times I did collaborate with companies. And I think, and even now as an academic, and now that I have a company, I think it's always important because like, hopefully what you're doing in the lab is going to be something that other people can use. So hopefully it should be of interest. So that was kind of, and I do always recommend that to everyone, and especially if you're out there trying to decide about grad school versus jobs. I think one of the really nice things about when I was at MIT, like I did work in academic labs, but every summer I did work in industry. So I got to see sort of both of the different things. And I usually recommend if people are unsure, even if you're a graduate student, and especially if you're a postdoc, like I always say, do it in a big city where you can go network with local companies as well as, get the experience you would need. And now I know it's a little bit controversial on Twitter, but I think it's really great because I see all these professors are complaining they can't get the same quality of postdocs because industry is paying more money. But I'm like, but it's good to show that what we're actually training people in is valuable.
Absolutely. And I guess in a certain way. So just to recap that idea. So what we're saying is that effectively, keep an open mind. Make sure that, network as much as possible with the relevant people in your industry. And at the same time, you may want to, recalculate your trajectory where you want to go. That's of course fine. But at the same time, it's really about, now, keep an open mind now, look after what you're trying to do right now so that, you will gain experience, not just in, let's say, books, as it were, but at the same time with the industry, right? So you kind of, broaden your horizons, you have a much more wider experiences. So then whichever way you want to go makes no difference in some way because you are already set in some way, because that's I think that's the important message, right? So that's a really key. And you have when you're in St. Louis, I mean, when you're doing a PhD, what was kind of different? Because I know, of course, that compared to MIT, that's a bit further away from, let's say, New York or Boston. Like Boston, it's a different place completely, I guess, compared to Boston. I mean, I'm not from the United States, but how was that different?
Yeah, well, I think one of the interesting cultural things, which is funny because I've always flip-flopped. So in the Midwest does have a very different culture from Boston and New York. But one of the big differences is that MIT is an engineering school. Absolutely. And it doesn't have a medical school, whereas WashU has one of the top medical schools in the United States. And so that really has a big impact on how research is done and how people think about research. And then it also brings in the whole patient aspects. So when I was doing my PhD in biomedical engineering, we collaborated a lot with a plastic surgery lab. So it really brings in a different environment. And even now with my lab, we collaborate a lot with clinicians over at the University of British Columbia. My lab is in our medical school. The other thing about St. Louis I think is a bit interesting is just like the lower cost of living.
Oh, that's right.
Was something that I think as a grad student was really good for me because, you know, I didn't have to take out loans, like everything was affordable. We had a lot of fun, honestly. Absolutely. It was one of those things where, you know, we were in the Midwest and like, it was right when WashU was like on the cusp of becoming like a top 10 graduate program. And so, yeah, it was a really fun time to be there because they had a lot of new, really talented faculty who are now like superstars in the field. So just had a really good, it was really a good environment, I think, in some sense, because it was less competitive than some of the other places I've been, like at Berkeley. It was definitely more of a communal vibe. Everyone was definitely cheering each other on. I just remember we were all, you know, like everyone was really supportive, like going to each other's defenses, like seeing everyone through to graduation. And so I think that was some of the things that were good about going to a place like that for your PhD. And I often mention that to students. I mean, especially, you know, now I'm in Victoria, which like Vancouver has a really high cost of living. You know, I think it's really rough. And I do know, I think the UCs, the California schools just got off strike to get better pay for their students. And I think that that's important for some of those high cost of living areas.
Absolutely.
Not to get too far off topic, but it also goes towards equity in academia. It's like, well, and you know, if you go back, you know, if you look at some of the history of academia, like the reason there weren't like, you know, that many women or minority grad students is it was like literally rich people were the ones who could afford to go to degrees. You know, even if you read about like I think even Watson and Crick, you read about them and like literally the men who were accepted to grad school would go like live with their professor.
Right. No, that's so true. Like you know, and it is an interesting, really interesting idea, right? Because I mean, you need to have a little bit of luck, of course, in a certain sense for everything, I suppose. But at the same time, we'll talk about that later. But at the same, you know, it's really about funding and, you know, having PhD students should not have to have, you know, scrape for a living, right? They should have a good, not, you know, good life so that they can focus on what they're trying to do rather than having to worry about their, you know, how they're going to make their living, you know, pay their rent, and then worry about how to do the research, right? There's a lot of stress already, and now you have to worry about something else completely out of your hand, and that's a problem, especially I would say it's in Europe as well, where there's, you know, lack of funding, right? So that's a bigger issue, I would say. Yeah, go ahead, please.
Oh no, I was gonna say, in Europe it's interesting because there I think you guys have very strict like limits, and then they're like the funding's cut, which is
absolutely
like, frustrating.
Absolutely. So let's have a little break and then talk about your next book that kind of made a very big impact on your life. Please tell us about that.
Oh yeah, one that another book that I read I think a lot during my postdoc when I was applying to faculty positions was Ring of Fire, which is the inside story of Valentino Rossi and MotoGP by Rick Broadbent. So I've been a big motorsports fan my whole life. Being American, it was originally IndyCar and then NASCAR, and then in college I really got into Formula One. And but even though this book is supposed to be about Valentino Rossi, I think the thing that's more interesting about it is Nicky Hayden's story, who although he tragically passed away a few years ago, Nicky was an American MotoGP champion, and he overcame a lot of different obstacles. So for those of you who don't know who Valentino Rossi is, but most of you probably do, he was one of the winningest motorcycle riders of all time. And then Nicky was this upstart American, and they competed for the title. And nobody thought Nicky had a chance. His teammate wrecked him out in the second class.
True underdog, right? Yeah, exactly.
Yeah. And then when Nicky actually ended up winning the title, they actually shut off the celebration in Rossi's colors, because that's how little chance him. So it was one of those books that really gave me a lot of motivation to keep going. When you read, and he's just like was a super nice kid from the South, and so he like couldn't figure out why Valentino was being mean to him. And then after he won the championship, Valentino was like, "Well, I did see you as a rival." So It's a really good book about not just Nikki, but all the other writers and what they go through. But yeah, I always like to read sports books for inspiration, because it's a little bit different from the science books, but still, is always motivating.
Absolutely, absolutely. It's a lovely choice as well. And going back into our conversation, so you've finished your undergraduate, you finished your PhD, and of course, then the postdoc life starts, which is a very different life altogether. How was that like?
Yeah, it was a bit different for me. So my husband and I, we've been together since undergrad. And so he followed me to my PhD. So then he got the next choice. So we were living in California, and I had a long commute. I was working at Berkeley. And I think when you're a postdoc, and also when you're a grad student, for all the postdocs and grad students, it's very normal to have a lot of angst about your future, because it is so uncertain. So I had a lot of that postdoc angst of like, I really want to get a faculty position. Will I get a faculty position? While at the same time you're trying to publish. So I was like interviewing out while working on this HIV project. I did like Berkeley was a really interesting environment. And it was great to be around lots of really talented people. I think one of the really key things was like our lab was bigger, but it was good for like when I was interviewing, because everyone would give you really good feedback. The other thing I will mention, another benefit of being in the Bay Area is there's so many great biotechs. So like I was able to go tour like Genentech, and I will say, like part of the reason I wanted to be an academic was because I am very independent and I wanted to implement my own research ideas. But there's also a ton of really good science that does occur in biotechs, especially at companies like Genentech in the Bay Area, where, the researchers are the same level, that academia recruits, and they publish in, the same top tier journals.
And when you in that postdoc time, when you were a postdoc, as well as then, of course you had your sights set on becoming, being successful in your career. What are some of the challenges you had that you really like almost want to say, maybe challenges, but at maybe also failures that you may think that actually I should have done it differently, or how you may have want to improve something that maybe even as a challenge where you may have even had doubts about where you're going. I'm sure a lot of people as you're saying earlier, have that, right? So what are some of those challenges so people can relate to that, I'm sure, and then how did you overcome that?
Yeah, I think one thing as I mentioned, when I chose to do my postdoc, it was really based on, my husband really lived in California, so I didn't choose to work on the project. So I was working on a project sequencing HIV from patients with a company called Virexis, which was very different from the stem cell work I did as my PhD. And so a lot of times I was like, did I make a mistake by, following my spouse's career? Which I think it's always really important to point that out, because I have given a lot of these, you're a successful professor, and then everyone's like, oh, you had this like very perfect career path. And I'm like, it only looks that way in retrospect. And I think that's important for everyone out there to hear, is that like, all of your experiences will lead you to, and obviously I say this from a position as now a tenured full professor. So it's very easy to say at the end of your journey, like,
worth it.
Yeah, everything I learned made it worth it. But when it's, when you're commuting 2 hours a day and your experiments aren't working, and you're like, I could be somewhere else working on stem cells. It's easier to think that. And as I said, at Berkeley, it was a bit nice because there were like so much industry. So it didn't ever feel like I was necessarily trapped, because like people could go get jobs in the Bay Area, in the areas I was working in. But I always was really like, I think I was meant to be a professor. And that was always the goal. But as I said, this is like how I turned out. But like I definitely did also apply to industry jobs at all stuff. And I did always keep strong ties with them, just because, again, you don't know how things turn out.
Don't burn your bridges, right? Of course.
Yeah, and I think that that's something that, and I'll say I was bad about it, especially when I was at WashU. I always say that they like literally would buy a keg of beer until like the engineers to talk to the business students, and we would like just drink the beer and not talk to them. And so I'm like, no, you should actually, yeah, I was like, you should actually network. And I know that as an engineer, and I think that's why I mentioned The Girl's Guide to Hunting and Fishing is like my first book, is because, you know, as engineers, you want to think everything's objective and all these things, and relationships aren't important. And then all of a sudden you realize, oh yeah, like everyone, like you should actually be networking.
Absolutely.
Yeah. I remember when I was an undergrad, my professor was like, do you want to go to a conference? And I'm like, no, it's going to take me away from like my classes and doing my actual research. And then I was like, what was I even thinking?
Yeah, I completely relate to that because, you know, when I was in my undergraduate and when I was doing my PhD, I was in that same mentality. I was like, okay, I want to focus on what I was doing. I was my simulations, what I was running or whatever I was doing, rather than, you know, actually speaking to people about what's going on. And every time you speak to someone, you actually get new ideas, you get new, and it took me a little while to realize that actually speaking to someone, just, it might be like, as they say, you know, shooting the breeze. It's still, you know, really important. It just, something just happens in your mind that really allows you to recalibrate and really think about things differently. I think it's a really important thing. And was your spouse or your fiance at the time, how like was he, when you were trying to, of course, doing that, you know, follow your career path, how was he help? I mean, what was his dynamic like? I mean, how was he helpful? In the sense that, the reason why I'm asking is that, going back to Professor Frederick Snyder, he was telling that, you know, a lot of people who are in academia is always, our spouses are also academics, right? Because it's called a two-body problem. I think it's like it's a joke, but that's what it is. But how was that like?
Oh, so my husband's not an academic. He is a programmer.
All right.
And so he doesn't, like, sort of the deal was like, he knew that the big choice I would get would be the faculty position. So Absolutely. He was like, I want to live in California, so we're going to live in California. And so he does have flexibility in where he goes, but also now at this point that we live in Victoria, you know, there are places he won't move. And so, you know, it's nice. I know, like, there's some crazy statistics. So I'm an outlier that my spouse is not an academic and he doesn't really pay attention to any of that stuff. Like, he'll like touch on it briefly, and sometimes with the news articles he'll see stuff I'm doing. But I think it's good because, like, academia can get so weird. I also have a group of friends who are like normal people. So when I'm having problems at work, I can tell them. And so then they can be like, Stephanie, you know that, like, that's all completely unreasonable. And so I do always recommend that for graduate students, is to have like some normal friends in academia, so they can at least tell you when everything's being super unreasonable. And
I also feel that it's a very good way of practicing what you learn, right? In the sense that when you try to explain something super complicated to someone who does not understand anything that you're talking about, that's a very good way to know that if you understand the subject yourself, right? Because if you can explain to somebody who doesn't know anything about it, I think that probably is a good indicator that you know what you're talking about, I think. Like, you know, yeah. And as a female working in engineers and working with, you know, very, let's say, male dominated environment, was that different in when you're doing a postdoc as well as when you were moving forward?
Yeah, it was really weird. It was interesting because, so when I was an undergrad at MIT, even though I think at the time MIT was like 35% women, I was in a sorority and I had a lot of girlfriends. But then when I went to graduate school, I think we had 3 girls out of 18 my year. But I did make friends with, WashU has a large medical program and a large biology program. So that's where I found women friends. Weirdly, at Berkeley, my postdoc lab was, I think, half women, which was really nice. And I played on an all women's soccer team that was super supportive. But then, when I came to Victoria and I joined, because my appointments are both in mechanical engineering and the medical school, the mechanical engineering department definitely did not have very many women. And definitely when I taught, the classes were very male dominated. And then as I've done different leadership positions in academia, it's still very, especially in engineering, very, very male dominated. I've also noticed that a bit with the entrepreneurship stuff. So like I went to Falling Walls and I was the only woman CEO who pitched, which was a bit disheartening. Hopefully we can get those numbers up. So.
And I remember the same, because I think I was telling you the story that in my first year at university for engineering, I was doing aerospace engineering, and there was a full lecture hall full of guys and like 2 girls or something like that, right? So which is kind of, as you say, kind of disproportionate, but I hope, that this was a while back, so I hope things have changed now, and hopefully it will change in the future. So let's go back to our discussion about books, and tell us the next thing. It's a great choice that you have. Please tell us a little bit more about that.
Yeah, so this is a book that came out more recently, but definitely of interest, and it's The Code Breaker, which is Jennifer Doudna's Gene Editing and the Future of the Human Race. Her lab was upstairs from the lab I worked in at Berkeley. And that was when they were actually discovering CRISPR. So this is a really fun book to read from that sense, where you recognize everything that like they're talking about in the lab spaces. And I remember at the time, so I was working on an HIV project, but obviously the whole gene editing thing was huge at Berkeley. And I think CRISPR is a really powerful tool. Something that's been really interesting to me for that, and it's not a secret, there was the huge controversy over the IP associated with CRISPR, and my 2 alma maters went to war, MIT and Berkeley, which I actually have taught, because they both produced very slick videos, each trying to defend their case, and there was a lot of drama and politics there, which again, like there's this whole notion of engineering or science being this objective ivory tower, and so that's it definitely can get messy with how the IP got enforced, and so I thought that it was interesting to see that from her perspective in the book, and just sort of the different players in this. And then obviously she and Emmanuel did win the Nobel, which I thought was the most interesting thing, was that MIT was super into litigating on the IP, whereas all the scientists were like, well, it was Jennifer and Emmanuel who did it. And so I thought that, and also and all the academic inside baseball, but it's a really well written book, and and again, and also just for all the grad students and postdocs out there, definitely I think it's good to read, to learn about the issues with IP and how to protect your IP in an academic setting as well.
Yeah, absolutely. Yeah, that's a great choice, actually. And going back into our normal discussion. So you've been a researcher for a while now, and you've seen so much, you've done so much. What are some of the issues that you see right now in research, and what are some of the things that we can do to improve? It might not be something that we can do directly as people, but at the same time, it might need government funding and government input as well. But as a professor right now, what are some of the issues that you see that may be having an impact in the future for the advancement of science effectively?
Yeah, well, I think one of the things, especially I was in the American system, and now I've been in the Canadian system for 12 years. Like, I think it's become a lot harder for new researchers to get funding, which is really disappointing, because like really the new researchers are what's going to drive your research forward. They're going to have the newest ideas. I mean, I run a large lab, and I don't know if I should openly admit this, but look, if you give a grad student to a brand new professor, they're going to get the best training, because the professor needs them to succeed for them to get tenure. Grad student wants them to succeed, so their PhD will be worthwhile. And so it's been really frustrating, because when I started in Canada, and granted it was like a little bit of a naive perspective, I moved up from the States, where the NIH obviously has a very low funding rate of like 10%. So that's where I came from, where I was like writing grants for my boss, writing my fellowships, getting funded, like 20%, 15% of the grants got funded. And I come to Canada, and I wrote my discovery grant, which is like our basic NSF science grant, got it. I wrote for an equipment grant, got it. Wrote for a second equipment grant, got it. So I got my first 3 grants, and so that really set me up for a good career. And then now the 2 types of equipment grants that used to be like very standard for new professors, they've changed the rules, so they aren't like that anymore, which seems a bit disappointing. Because that's like who needs money and resources the most. are the newer professors. And so I think that's something that's trying to really encourage that. I've also noticed both in Canada and Europe, the governments tend to go towards these more shiny, and I'm on one of these. I'm on Mend the Gap. So Google that if you want to learn about how we're curing spinal cord injury with it. And I mean, it is always amazing to be part of a $25 million a year grant. But they have a lot of these, moonshot. In Europe, you guys have the Horizon 2020 program, which I reviewed for, that are these huge multi-institute things. And I do understand that there's a need for these big projects. And it does, for curing spinal cord injury, yes, it's going to require a huge international team, but there also needs to be funding of, just normal researchers to do what they do. And I think that that's something that in Canada, they've definitely got away from funding like some of the basic science and engineering work. And again, supporting new professors. And I think, some of the more niche stuff where it's still like really solid science, but it's not necessarily, because there are people who do a lot of theoretical stuff that don't need $25 million. I feel like some of those get lost when you're funding just these really huge projects.
And I think is publishing a problem as well, in the sense that, say, for example, you are working in multidisciplinary kind of way, right? So you're working in engineering and you're using biology, another subject, and which might be STEM still. And then other things that might also come into it. Is collaboration an important part of that? How does the collaboration work? Is there kind of boundaries to that? And once you publish, once you've done your research, is it difficult to publish in a more like in a specific journals, or is it much more easier to publish?
Yeah, I mean, it's interesting with bioprinting because it is so interdisciplinary that it's really been all over the place where our work goes. Because some of our, Ruchi from my group, we published a novel bioink that we're now commercializing called Brainprint in Frontiers, whose impact factor is like 5. And that paper's been cited, I think, 90 times in the year since it's... And so for me, it's been really interesting because I guess the issues I see are, so for some of the nature journals in the field of biomedical, they'll request, $500,000 worth of experiments, which a normal non-NIH researcher, I can't, there's no pot of money that you're like, oh, here's $500,000 to revise this paper. So I think that in some sense, at some of those journals, there's a bit of gatekeeping just because they expect you to have a certain level of resource. The other thing that's I wish the journals could get together is the open access thing. Even though some people don't like them, I like the MDPI model where when you review, you get credits. So then you can use those to get your open access fees covered. Because I honestly think one reviewer should be compensated for their time.
Right. Of course.
And two, I actually think science should be open access, which is why we tend to publish more there, which I actually think has helped us on the company side, even though we haven't always published in the highest impact factor places, like I said, with Frontiers. But because it is open access, so many more people and so many more journalists can read it. Yeah. And that's what I honestly want, is a more educated population. I would rather have people reading the actual research itself than, a newspaper version. But with some of the things like Nature Communications, the open access fee charged by Nature is $11,000, which again, not as I said, in the grants I have, it's where would you find
that much money? Yeah, exactly.
This much money. With collaborations, as I said, it's been interesting, especially with bioprinting, because really there's some stuff we published, which later I was how did they not ask us the mechanical properties? And so it really just depends also on what reviewers you get and what strikes a note with them, because we were doing really cool biology. Some of the journals are more focused on mechanical properties, and so it's actually been a really interesting, especially when you're doing interdisciplinary stuff, it's always where should we go? Are the people we want to read this going to see it in this journal? Especially with some of our clinical collaborations where, they want to go to more clinical neuroscience journals or clinical biology journals. And then again, that also affects the type of reviews you get and then the kind of revisions you have to do.
Yeah, absolutely. Do you kind of start, I mean, it's maybe it's a bit different to science versus more, other subjects let's say psychology or economics and things like that. But do you start with a a particular audience in mind when you start doing research, as it were, or do you just start with a idea? It doesn't have to be something that would appeal to anybody or not. It's just a great idea that you start off with, and then you start to kind of focus that into something that is productive, and then get the experiments done and so on, and then think about publishing? Or do you kind of think about the whole journey and the life cycle of everything from start to finish, and then say, okay, this idea is amazing, but I don't know if we can publish it, so I don't know if that's worth it?
Oh man, we're more, I'd say we're more on the looser side, where I give my students a lot of freedom. I mean, we have like the broad strokes where it's like, okay, we're going to bioprint an Alzheimer's tissue model, but they get a lot of leeway in terms of, you know, the experimental methods, how they culture. I mean, we go back and forth and we talk about it, like what formulations to use, what settings to use, what'll be, you know, like sort of to get the experimental design down. And then, interestingly, there was a year, I think, where we were just submitting things to journals that had invited us to submit, and then all of our stuff got cited a ton, and then we were like, okay, we need to actually start submitting to better journals, because everything we're submitting to is like getting cited like, you know, like 100 something times, and factor of 6. So yeah, that's kind of where we've been at now. Also, like, I think it was like there was a point in my career, I think at some point where, you know, like all of a sudden, and this is again for all the graduate students, but there's a point where it does get easier. There's
absolutely.
Where you've published enough, and then it goes from like, and this again for a grad student postdoc audience, where it goes from where you have to write your grant to like prove your lab has all the expertise, where then all of a sudden reviewers are just like, oh yeah, like they've got this, and then like it can really be about your ideas. So that was kind of an interesting shift, and that also gave us a bit more stability in terms of our lab funding to give it. And that's the other thing I'll point out is you need funding and stability if you want to go after some of these higher impact factor journals. For some of our bioprinting stuff initially, you know, it was like we just needed it out to show that we could do it. So we couldn't spend, you know, a year doing experiments to get a paper out. So those are things to think about. Is just like the trade-off between like, do you want it out so you've got it established that you can do it, versus do you want to go somewhere high impact?
Yeah, absolutely. And then the one final thing I wanted to ask you about this, some of the things I've seen online as well on Twitter, is that the relationship between the professors or the teachers, as it were, and the students, right, or the postdocs. So some professors are, of course, much more helpful, really, trying to get their students to be successful. But some professors are much more focused on getting funding. They're spending a lot more time trying to get funding, where they don't have enough time to actually help the students, to guide them to do, and they feel lost, right? So it's not the professor's fault or the student's fault in some ways, but do you have some suggestions to kind of manage that relationship between the professors and professors as well as the students?
Yeah, for sure. So I had been in similar situations, and then that's when I started reading books about like how to take control of your career and how to manage your boss. And so honestly, if your boss is spending all their time writing funding and can barely remember what your project's about, then just when you meet with them, have detailed agendas and have your points, and then make a summary of it. So then they know. And then, like, for example, if like writing your paper is important to them, you really honestly just have to keep bothering them. I try to be on the ball in my group about, reading papers and submitting papers, because I do know that's important to our team. But yeah, I do know that some profs with like the funding and things, you need to just constantly remind them. The other thing is you can always offer, because I definitely did this as a postdoc, where I was like, can I like edit the paper? Can I upload it? Can I do all the stuff you would do just to get it off their desk? And my postdoc mentor was happy for me to just take control of the whole like paper submission review process as well. And then also, I don't know if you're in a postdoc position, you can also, have other students under you who can also help you with your writing and your tasks, which I definitely, when I was a graduate student, like I co-author papers with all my undergrads. Currently in our lab, we have a very collaborative environment. And I will say it's a little bit different because most of my students at UVic don't want to become professors. They do want to but they want to go to industry while staying in the area, because like Vancouver and Victoria is really nice. So we have a really collaborative, so a lot of our undergrads publish both research papers and review articles. And it's been good because I try to emphasize that we are all a team working together. And so I think those are some things, but I do know that there are difficult environments. So usually, keeping track of stuff so you have a record, so then you can go over it with your boss, because probably if they are not remembering things, it's good for you to just keep a record to do that. And also just read it, managing up, because like sometimes there are things, if you can help them with some stuff, or even, and like it does help you to write, even though you might not get credit, writing grants for your boss is helpful if you do become a prof. Which I try to remind myself whenever I get like tired of writing grants. I'm like, you wrote grants for all your bosses, so you should at least be able to do it for yourself. So.
Absolutely. That was great advice, and it's something that will help you regardless. So might as well start doing it. You might get it wrong, you might get it right. That's okay, but keep doing it. And it's not really about getting recognition at that point in time. It's more about like getting the hang of the process, understanding the little details about it, so that if nothing else, you'll be successful later on, and the work that you do would be useful and helpful to you. So let's go back to our little bit of an interlude, and tell us a little bit about your next book, which is actually another book that is really great as well.
So Projections by Carl Deiseroth. He invented optogenetics. So he's a professor at Stanford who's an MD PhD. And I think, and as I mentioned, my lab does a lot of neural tissue engineering. So I was very familiar with his research side. But the interesting thing is that as a practicing doctor, he was a psychiatrist, I think. And so it was really interesting because the book goes between treating his patients, but also his research and his story. And then as a person in the area, I tell this like to all my students, because especially given like my lab being joint with the medical school, I get a lot of students who have gone to med school who are deciding between med school and graduate school. And I think it's a lovely book that shows the differences between the two, but also how they can work together. And it was just really well written. So highly recommend, especially if you're having some of the angst about what you want to do in your life.
Yes, absolutely. Thank you so much for that choice. So now, of course, you're a full professor, but you've kind of moved on even to more challenging situation, I guess, being an entrepreneur and a CEO of a company. So you're kind of leading not only in an extremely competitive sector, but you're doing it in almost in a different sector as well. Even though there are synergies between it, they're completely different challenges and completely different problems to deal with, right? So first of all, tell us a little bit about your company, and how did you decide to take on another challenge that is even, I would say maybe bigger than what you even had before? How was that? Why was that in start of it? What was your motivation?
So my lab focuses a lot on bioprinting human tissue models, particularly neural tissue. And so when we had started working with bioprinting, a lot of the bioinks weren't very sophisticated. And so if you tried to print delicate neural stem cells with them, they would all die. And we had some biomaterials that worked really well at keeping neural stem cells alive and making functioning tissue. And we made a printable version of that. And so we published some of the papers I had mentioned earlier that got a lot of attention. And we actually had gotten, in Canada, there's a lot of money to commercialize technologies. So we'd gotten a lot of these grants. We had been protecting IP. And honestly, it was one of those things where, I always say pre-COVID, I was like the happiest person on earth. I got paid to give talks in like fancy locations like San Diego. We had plenty of grant money. The team was doing really well. But I was at a conference in fall of 2019. And I was talking with, actually a professor cornered me, because at the time we had a lot of collaborators. So we were sending our bioink to people in the States and in Canada. And so this guy cornered me and was like, why aren't you selling your bioink? Like, it's not fair. The only way you can get your bioink to print these stem cell tissues is like collaborating. You need a company. And I was like, okay, it's like a reception. So I'm like, okay, like drank my drink and went on with my life. But then I was talking to Eric Gadom, who's the CEO of Bico, which at the time was selling, who made all the bioprinters. And we had known each other for a while. We met in like 2016 in San Francisco. And we had would always chat about bioprinting. And I'd be like, okay, but you really want to bioprint stem cells. And Eric was like, we were talking about the different bioprinters on the market. And then he was like, well, why isn't our company selling your ink? And I was like, oh, because previously we were working with a company who's great called Aspect Biosystems out of Vancouver. They have a really fancy high-end bioprinter that can make really sophisticated tissues, and they've since like pivoted their business model to be on making tissues for clinical transplantation. But they didn't have that many printers worldwide. So, I was getting grants and we're like, yeah, we're going to sell this, but we were already shipping our ink to like most of the people who had the Aspect system. So it really wasn't a business model. But then Cell Ink has thousands of printers worldwide. So then all of a sudden I was like, oh, wait, that's a company. And so then we put together a business plan. My PhD student, Laura, who's also one of the co-founders, she had always been interested in entrepreneurship. So she was like, great, finally, we're starting a company. And we won internal competitions. We incorporated the week of the pandemic, do not recommend. We got a bunch of government funding. So that summer we were up to 5 employees, and it's really been a crazy ride since then. But we commercialized our ink. We have a product on the market. You can check out our website. It's a bit of different skills, but a lot of it is transferable. I write a lot of grants on both sides, budgeting, managing people.
Yeah, of course.
Yeah. Pitching's been a bit interesting with the company. And actually there's things that I really like about it that, given I was always one of those people who's like, I'm never going to have a company. For example, like optimizing our ink manufacturing process. I was like, man, we should have actually done this like when I was in grad school. Because when you're in grad school, you do things like till it works and you have the N of enough to publish. And so you don't really do the process optimization. And so a lot of that stuff I've really grown to appreciate. And also there's a bit more freedom with the company just in terms of, what we can do. The other thing that's been really exciting is with all of our beta testers and customers is seeing people print all sorts of tissues we would never print in my lab.
Yeah.
And so that's been like the most exciting thing. Unless you're an investor, which is, axolotl is a great business proposition, but really expanding the amount of science being done and seeing, it's like having mini labs where you can see all this science being done where, we don't have the capacity or, never write a grant to do that kind of thing. So that's been really exciting. And also seeing my employees grow because like all of our initial 4 are still around, and Misha, who's the only one she's actually graduating this semester. So, but yeah, so it's been really nice seeing our team evolve.
Absolutely. And first of all, congratulations! It's a brilliant endeavor. So just because anybody who's listening, if they want to contact you, how would they do that?
I would probably say easiest way is to just email my email at UVic, which is willerth@uvic.ca. You can Google my website. There's also like contact forms on the Axolotl website too.
Absolutely. And all the details will be available in the show notes as well, on the web on our site as well. So you can go from the podcast directly to Professor Willerth's website as well. So that will all be available in the show notes. So thank you for that. And just one last question. If you wanted to, this is probably a bit of an abstract question, but if you have had an amazing career as we've discussed right now. And if you wanted to thank someone that maybe you didn't have the chance to say it, or maybe you didn't really think about it, if you wanted to thank anybody at this point in time to the journey that you've come so far, who would that be?
Oh man,
so many people.
Yeah, obviously, always grateful for all of my team members, both at the Willerth Lab, Axolotl. My PhD mentor, Dr. Shelley Sakiyama-Elbert, was amazing. I think she knows that. It's been very interesting starting off as her graduate student, and now she's the Vice Dean of Research at the School of Medicine over University of Washington. So it's interesting now that we're both super established. But yeah, she was a really good role model. And then it's always funny, all the things that, when you're a grad student, your boss tells you and you're like, this won't apply to me. And then it applies so well. So yeah, those would probably be the main groups.
Awesome. So thank you. And one final choice of your book. Please tell us what is your final pick.
Oh yeah. So it's a sci-fi book called This Is How You Lose the Time War. And it's sort of time travel, but really well written about, 2 different groups battling in the future. And it's just a really elegant plot, a really nice read. For those of you who are looking for something different that, I guess I have two fiction and 3 nonfiction books, but
yes,
yeah, always down for really, really good, pretty sci-fi, well written.
absolutely. It's kind of always good to unwind, and to have a nice glass of wine and really read something like that. It's probably something different to do. So thank you so very much for your time, and I really, really appreciate it. All the details of how to contact Professor Willerth and all her works, as well as the choices she made today in her books, will all be available in the show notes. And finally, is there any other final message that you want to give anybody?
I would just say, I think engineering and science are amazing, and it's interesting because as a woman in engineering, like there are challenges, but it's been I'm so happy with my career, the science, the students I've mentored, and I think it's a great career path. And I always wanted to encourage more women to go into engineering and science, just because I think it gives you so much control. I think being a professor is sometimes underrated in terms of being able to choose what research direction you do. Being able to mentor students, and then I think it's still a really exciting career path. Yeah.
Absolutely.
And thanks for having me on. Yeah.
It's absolutely my pleasure. So thank you so very much, and especially joining us on a Saturday with I'm sure you have 1,000 things to do. So thank you, and hope you have a very nice weekend as well.
You too. Thanks.
Thanks.